Okay, so if you see, quickly switch on to Chrome. Okay, this is the data set that we are talking about. Okay, let's see if we refresh, do we get this or not? Yes, I told you this is in machine learning. So when you go to github.com/Swapnil Saurav, single word, /machine learning, you will get all the data set that we will need to learn machine learning. So this is the data set which is designed specifically for data cleaning process. Okay, here the three main steps that we generally perform: data cleaning. Okay, in data cleaning, one is your missing value. So here, see here, the quotation is missing here, right? So before that, here you have east 40 and quotation is missing. So we will replace with the right quotation value. Then here salesperson is missing, not blank 42,000. No, here salesperson is missing. So we will replace a salesperson here. Okay, so it's the missing value. Then for feature scaling, you see the salesperson is 2 digit and quotation is 5 digit. Okay, they are not balanced. We will learn how to balance it, and then we will also talk about your handling the region. Okay, handling the region, because here we have region, and as I said, region cannot get into analysis just like that, right? We have to handle it. Okay, so we'll learn how to handle it. Okay. Now, if you look at the whole step, whole process, okay, there's one more thing we discussed was breaking it into training set and test set. Okay. Some people, okay, some people break the data set into training set test set before doing all the pre-processing steps. Okay. Um, okay. Now, why do we do breaking into training set before and after is, see, when you are performing um, all these steps, when you're performing all these pre-processing steps, okay, you are doing with respect to the column. So what I mean by that is, when you are replacing the mean value, sorry, when you are replacing the missing value with the mean value, okay. So clearly, okay, when you see a mean value, okay, you calculate the mean value of the column. If you see there's a mean, that value is almost equal to mean value, you can guess, right? Or probably this was, see, generally, very rare to have some mean value, right? You'll have less than or more than. When you see something like mean value, you know that, okay, so let's say, here, let's assume there are two columns blank. And if the two columns were blank, okay, and of course the mean value of this column will be same. So two values will be replaced with same value. So when you are looking through it, or when machine is looking through this column, algorithm is looking through this column, you'll see that, oh, there are two columns, okay, two values with same, two columns with same value, okay, and two columns with same value. And if I, remove those two columns and calculate the mean, it is same as the mean value of these two columns, correct? So in a way, you are uh, giving hint to the machine learning that these columns were blank and have replaced with mean value. Understood what I'm saying? Okay, by looking at it, you can quickly calculate and see, oh, you can predict that these values were missing, so the user has replaced with mean value. Similarly, when you do this scaling, okay, and if you see the columns, all like here you have two columns, let's say you have 10 columns, and all 10 columns are in similar range, -3 to 3 range or -1 to 1 range. You can assume that these were uh, uh, they have done the scaling, okay. And when you, in training set, what we do is we take out some column, okay, right? We hide some column from machine learning, right? We hide some column from the algorithm, right? So that algorithm will, we will use those hidden columns, right? What is the training set and test set, right? Training set is the 80%, 70%, 75% data that you give for model to learn, and the 25, 30 or 20%, whatever is remaining, you hide it to test it. No. Okay, so before coming to scaling, I'll tell you, like say, if there are 10 questions with me, okay, if I give you question 1, 3, 5, 4, okay, 1, then 3, okay, then 4, 5, let's say I don't give you 6, 7, 8, 9, 10. I don't give you 2 and 6. So when you see the 2 and 6 questions are missing, then you can probably guess, right? Or second questions, maybe, teacher has hidden for testing. See, generally, when you expect question numbers to be given in an exam or teaching, you will expect 1, 2, 3, 4, 5, 6, right? If you hide second and sixth, okay, so that from giving it to the student, then they'll start thinking, right? So why question 2 and 6 is not there? Probably 2 and 6 question will be given to me later to test, right? Then you'll start thinking, okay, where these two questions are, right? Focusing on you will not be focusing on solving the problem, but rather looking for some kind of connection, some kind of relation, because you got a hint, right? So that's what we do is when we perform this scaling, okay, at least what I do is I do scaling after dividing into train set and test set, okay, because you don't want any hint to be given to the machine, okay, that this could be the values, okay. You want machine to solve. Okay, see, why do we do the test and why do we stop people from copying? Okay, if you are teacher, okay, you could say, okay, copy whatever, you get 100 marks, I don't care, right? No. Why do we stop people from copying? Why do we make sure that people do not copy and they write based on their capabilities? Is because we want to genuinely know who is able to perform better, right? You don't want to reward the wrong person, right? Who has copied and got it versus somebody who has, had put in effort and okay. So what I'm trying to say here is same thing with algorithm too. Okay. You want the best performing model, not the model which has guessed correctly. Because again going back to the example here, okay, let's say you want to guess if tomorrow is going to rain or not, let's say. Okay. So you have a 5-year-old and you have a 40-year-old. Okay. Now you ask the 5-year-old whether it's going to rain or not. Okay. 5-year-old says, yes, it's going to rain. 40-year says, no, it's not going to rain. Whom will you believe?
40 years.
5 years says, no, yes, it's going to rain. 40 years says, no, it's not going to rain. Whom will you believe?
40 years.
40 years. Now let's assume that, this 5-year got it right. Okay.
Hmm.
It rained. Okay. Next day it rained. Okay. So, 5-year got right, 40-year got wrong. So next time again, if you are predicting and they tell you opposite, okay, 5 years says it's going to rain, 40 says no, it's not going to rain. Whom will you believe this time?
Again 40 years.
You will again believe 40-year-old.
Yes.
Okay, you will again believe 40-year-old because the 40-year-old probably is able to process multiple variables, multiple reasons why it's going to rain or not. Maybe 5-year-old is not able to understand all the concepts. Maybe just sees it's okay, it's raining today, so tomorrow it's going to rain. Today, okay, but 40-year-old is going to look at temperature, weather, look at the history of which month is it rainy season or not. In monsoon, you expect to rain, but during non-monsoon, you don't expect to rain. Okay, so your 40-year-old is able to think multiple variables in her or his mind and then give you the answer. 5-year-old, okay, has not seen many seasons, right? Is not able to predict based on that. So ultimately, what you're believing is the experience, even though they get it wrong. So same thing in machine learning also. See, we want machine learning algorithm to think and then do work, not because okay. you get it right once, so you'll always get it right. There's no guarantee, right? That's why in jobs, you see, people don't hire the top performers. So they don't say, okay, you have 90% come, I'll hire you, right? Whether you got 90%, you got 60%, or you got 40%, you have to go through the interview, right? Why they don't hire 90%, right? You get 90% in one exam doesn't make you 90 percentile, right? You could have got it for various reasons. One could be that you were lucky. What questions, the topic that you read, you got same topic, you got high mark. So why I'm giving you these examples is same concept applies on machine learning. You want algorithm which thinks. You don't want algorithm which is guessing, right? So when you perform all these steps, pre-processing steps, in a way you are making, okay, you don't want machine learning model to guess. Okay, see, it is when we say machine learning, like in human, when we try to do something, we might be biased. We might be biased because of various reasons, you know, biased because of gender, caste, okay, language, right? Whatever. Oh, he is from my village, okay, let me give more marks. Right? Various reasons. He's my friend, let me give more marks. Right? There could be various reasons why human being can get biased. But in algorithm, we don't expect algorithm to get biased, right? But data itself, if you provide bias, then machine learning algorithm will also get biased. You understand what I'm saying? If your data itself is biased, algorithms will also get biased, right? Now, classic example is there is one algorithm which is used for face detection. Okay. Now, in face detection algorithm, it works very well for white male. Okay, almost accuracy is like 99%. But for black male faces, okay, the accuracy of that it was developed by IBM, this data set. Okay, it was like 60% because the data itself has more training data. Okay, the data that you provide for training has many more white male data to it. So if you provide much more white male data to it, so it is able to predict, okay, white male faces much better than black male, because so by the way you provide the data, you made machine bias. Machine as such has no biasness towards anything or anyone. But if you manipulate the data, if you do not give the right data, okay, your machine learning can become biased. Okay, so generally, when you perform all this pre-processing, you should make sure that you are not, you know, giving any trail for machine to think. One example is I told you, right? When you perform scaling after you are done with, okay, uh, um, uh, uh, dividing into train and test set. Okay, if you perform after dividing into train test set, the linkage that is created, okay, based on whichever step that we follow, that will not be visible. Okay, so just a warning here. Okay, this is a practical challenge that you'll face. Is be careful. Okay, be careful. Think of this situation. Okay, whenever you change the data, actual data, whenever you try to change it, you try to, whether it's through missing value scaling or through categorize, converting categorical value to doing column transfer on them. You have to make sure that none of these leads to a trail which machine can understand. Okay, so for that purpose, you can do your uh, missing value treatment and categorical value before training, dividing train test set and test set. But scaling generally we do after dividing into train set and training set and test set. Okay, so we'll see all those things. Let's get started. Okay, now I'm going to copy this link here. Okay, and I'm going back to my PyCharm screen. I'm going to share it now, and I'm going to say here import pandas as PD. Then I'm going to say data frame equal to pd dot read cs. okay, and I give the link here. Perfect. So data is there, and now let's divide it to x and y. Okay, okay. What is x? What is y? The variables that you think to
Need to
predict.
predict is y.
Sorry, I
What we need to predict will be on the y-axis.
what we need to predict is on y-axis. Perfect. And what are we predicting here?
Uh,
Win.
win
Yes
percent.
or
Yeah,
no?
win.
Right?
Win.
And the factors that impact y is x. The factors that impact y is x. Okay.
Yeah.
So I'm going to divide x. So x in this case will be column 0. See here, this is how the data set will look like, right? So this is 0, 1, and 2, right? So column 0, 1, 2 are your x value.
X value.
X equal to df bracket open. Okay, before that I have to say I log or log, right? I log if can use number, so I'll say I log all rows, comma 0 to 3. Okay, when I don't mention anything on the left of colon, it means start from 0. When I don't mention anything right of colon, it means go up to the last value. And before comma, it is rows, and after comma, it is column. So colon means go from beginning, go up to the last. Okay, uh, that means all rows should be taken into account. So take all rows, but column you take only from 0. And if I give 3, it means up to 3, right? Not including 3. So it is 0, 1, 2, right? So
Yes.
colon 3 means 0, 1, 2. So I am taking 0, 1, 2 as column. Okay. So first 3 column will be taken as X. So you have region, salesperson, and quotation. Okay. Then dot values. Okay. So this will give you X. Similarly, I need Y. Y will be a single column. Okay. So generally what we do is we represent Y with small letter. Okay. It's up to you. You can give any, this is after all a variable name only, right? So you can give any variable name, of course. But generally, we write X is capital to indicate that, you have multiple columns here, and Y just single column. And here, okay, I will not say colon, I will simply say 3. I need third column. So third column is 0, 1, 2, 3, fourth column, right? So
Fourth
I'll get
one.
win here as Y. If you want, you can print X and Y. So print X, print, okay, small y. Here I'm going to say print, print y slash n, and here I'm going to say x, right? Okay, so yeah, so see, it has divided into data set x and y. Y is a single column, so you have no, yes, no, no, yes, yes, no. Here you have, see, south, east, north, 40, 35, missing, missing, 40, 58, 52, all these things. Okay. Now, what is the first step that you think we'll do here?
We need to arrange missing values. Means
Handling of missing
handling of
values.
missing
Okay.
values. Yeah.
I need to replace this missing value, nan. I need to replace the
Yes.
missing value, right? Okay. So what I'll do, I'm going to say step 1, replace the missing value with mean value. Replace the missing value with mean value. Okay. Now, okay. Now to perform all these, okay, to perform pre-processing, perform machine learning, we need to use scikit-learn package. Okay, we need to learn scikit-learn. and it is called as scalar. Okay, when you write, you need to import, you need to, you need to first install using pip install, and then you need to use it. Okay, so how do we install scikit-learn? But before that, let's see what scikit-learn is. So we'll go back to our Chrome here, and I'm going to say here scikit-learn. Okay, this is the official website, scikit-learn, scikit-learn.org. Okay, this is the official website. Okay, so this is a machine learning algorithm. You can perform classification, you see, regression, clustering. These are the three things that we discussed, right? It is
Yes.
built on NumPy, SciPy, and Matplotlib. We have seen little bit of all these three. Yes or no?
Yes.
Okay. So this is the package which is what we are going to use. Okay. So see here it talks about pre-processing, model selection, dimension redirectionality. Dimension redirectionality we have not discussed. This is also part of your pre-processing. Okay. Um, okay. So what is dimension? Can you guess?
Mm,
Dimension. Okay. Each x becomes a dimension. That means if you have 2x or if you have 1x, it's a one-dimensional problem. If you have 10x, it's 10-dimensional problem. See, for us to visualize anything more than 3 dimension itself is very difficult, correct? Now, when you talk about 10 dimension, okay, you can imagine the kind of complexity. It will make your algorithm run very slow. So, in pre-processing, and this is what you will get after EDA before you actually, perform your machine learning, is to figure out which columns, okay, are important. Minimum x, okay, is what is required. Okay, minimum x, okay, minimum number of x columns. Minimum x, I mean to say minimum number of columns without impacting the accuracy of your model. It's called dimensional rationality. And there are different techniques we'll see. So you have PCA. PCA is what you're going to do, okay, principal component analysis. So there is a technique using PCA. You can actually calculate how much percentage influence each column has. So we'll see. You can see, to tell you, column 1 has 80% influence, column 2 has 60% influence, column 9 has 0.01% influence. So when you see column 10 has 0.01% influence, remove column 10, right? The column 10 is not required. So that's why you will be able to reduce your complexity by removing your dimensions, number of dimensions or number of x input columns. Okay, input columns removal will help you to make your algorithm run faster. Okay, run faster, because when you have less columns, it will be able to perform little faster than with more columns. But you are removing using a scientific process without impacting the overall accuracy of the model. Okay, without impacting the overall accuracy of a model. Now, okay, so now again here, your experience always precedes your statistical method. Whatever we are doing here is using statistics, right? But what general phenomena is that your statistics, okay, is useful when you don't know what to do. Okay, when you don't know what to do, that's when you will take the help of statistics. But if your experience says something else, then experience precedes over statistics. Okay. So even though dimensional directional is giving you a column which is saying that very less impact, but based on your experience, experience, of course, you will get when you work on more and more, right? More and more problems you work, you get to get more and more experience. Okay. But your experience is that, something is having more impact on the analysis, okay, on the model, on the prediction, you should include it. Okay, statistics is used only when you don't know what to do, how to do. How to do, of course, this will tell you, but okay, um, uh, should I believe machine or should I believe my experience? The answer is your experience.
Experience.
Okay. Now, these are some examples I'm going to give you. Please, once we are done, right, you go and do, right? Today, we are going to talk about pre-processing, right? Today and tomorrow, maybe. So, once we're done with pre-processing, then go and look at this example. Understood? So, you need to go and explore this, okay? There is very little we can do in the class, but I need you to practice more. Okay, this is important. This is why you guys are here. Okay, so please
Yes.
go and practice. More you practice, more experience you will get. Experience doesn't come with age. Okay, experience comes with working on that problem, right? I always say that, somebody who is 20-year-old but has spent 10 years in real estate industry will know more about real estate than somebody who's 40 or 50-year-old, right? Because it's about the relevant experience. For real estate, that person is more experienced than you, even though the age could be less, isn't it? Okay. So it's not about age. It doesn't mean that if you grow age, you'll get all experience. What you work on, okay? And as the policy of machine learning, we say as you provide more data, accuracy will improve, right? So we say that if you provide more data, accuracy will increase, but then we ourselves don't, follow that. If you want to become expert, if you are looking for a career change into data science kind of field, you need to practice more and more and more. See, no one, I mean, no two or problems are same. So when you practice more, you will actually see the difference between them. Okay, how is one different than other? What is the difference? What kind of data it is, right? And that will help you to face the interview. Okay, if you stick to only one example, you will only talk about in one way. But when you do 10 examples, 20 examples, you'll understand 10 different concepts, 20 different concepts. And when you speak, when you answer in the interview, your answer will be based on not just one example, but 20 examples. And trust me, the interviewer will be able to figure out, okay, when, whether you have worked on one problem or 20 problems. Some people do one problem and they think they understand the machine learning. Okay, they start interviewing and they give answer as if this is definite, this is yes, this is how it is done. Okay, there is no this is how it is done. It is always done in different problems, different ways. Steps are same 6 7 steps that we discussed. But when you do the model selection, when you do the pre-processing, you'll come across different challenges, different problems. And when you speak, your experience shows while you speak. Okay, that's what I'm saying. Practice more, practice more. It is very easy to understand the concept. With scikit-learn, it is very easy to do also. Okay, what is required from you is doing multiple examples. Make sense? So I'm going to put this link also here so that you go back, and that's the official website of scikit-learn. So it is always good to practice from there, take examples from there, from other places also, but this will be the first place to go. Okay, so we are going to use scikit-learn, SCI. Okay, we're going to we're going to use scikit-learn package to perform ML. Okay, we'll use different for deep learning. Okay, this is only for machine learning. Okay, and then how do you install it? You have to install it, correct? First, you have to install the package by typing pip install. Okay, pip install scikit-learn. But when you import it's sklearn, right? So I'll say import sklearn. But here I want to perform um, uh, replacing missing value. It's called impute. Okay, the process is called impute. So there is a model module, okay, within scikit-learn which talks about imputer. So here I'm going to use simple imputer from sklearn. I already have installed, so that's why I can directly use it. Okay, impute. Okay, from sklearn.impute, import simple imputer. Okay, so I'm going to, okay, this should be actually after this. Okay, now let's see how to impute it. I'm going to create an object. Okay, that's why we learned class and objects. I'm going to say imputer, which is your class imputer equal to simple imputer. This is the class. Okay. Okay, this is how you call a class, right? Object name B1 equal to book, S1 equal to school, right? So imputer equal to simple imputer, bracket open and close. So I'm creating an object of class simple imputer, right? Now there are some values this init takes. Init takes values like missing value. How will simple imputer know which value is missing? So see, it has converted all these missing values into nan, and this is no np. So I need to use, you need to import np also, numpy. Import numpy as np. So how to identify missing values? You identify missing values using np dot nan, np dot nan small. Okay. So this is how model knows. Okay, missing value is nan. Then what strategy? Strategy is what? How do you want to replace it? I want to replace using mean. Okay. So I just created an object imputer with simple imputer, object of simple imputer, and passing two values like how to identify missing values and what to replace it with. Now I need to apply it over the missing values, right? I need to apply it over column 2 and 3, right? That is index 1 and 2, isn't it? So I'm going to say here imputer, another variable, okay, okay, imputer dot, here you will see we'll be using, whenever we do anything, we will be doing using two process. We'll be doing using fit and transform. Okay. So either you'll have fit and transform separately or fit and transform together we will use. Okay. So fit is to fit the data to apply. Applying the concept is fit, and when you save it, okay, it is transform. Okay. So I'm going to say imputer dot, sorry, imputer dot fit. Okay, and now I'm going to say fit what? Fit x all rows column 1 colon 3. Okay, so 0 we don't need to do. 0 doesn't have missing value. Anyway, if 0 had missing value, we can't use mean on there, right? Okay, we have to apply strategy mode there on the column, because column is text. Text you can't apply mean, right? So if we had missing values in column, we would have to create another object imputer2, and then you would say strategy equal to mode. Okay, so it will figure out the mode and then replace the missing value with the mode. So imputer dot fit, okay, imputer dot fit x of all rows comma 1, 1 2 3. So that means second and third column you are saying impute. Now, if you see here, okay, I told you if I print x, okay, now let me comment the previous x. Okay. We don't want to see too many values in the output. This is after doing the fit, okay. Okay, so see, fit has not changed the x value, right? We have just said apply it on x. Now I have to change it. So I have to say x of all rows 1 colon 3 equal to, okay, this is still object only. Now when I do imputer, this imputer dot transform, imputer, right? Transform, it should be there. And then I'm saying transform X, all rows, 1 to 3 column. Now you see, okay, your X will be transformed with missing value replaced with mean. See here, 62,230.769230. It has calculated the mean of entire column and this is replaced here. Similarly, here it has calculated average of entire column and replaced here 37.5384. So this is how you can replace the missing value in a column using simple imputer method of sklearn. Simple imputer, not method, simple imputer function. Not function, class. Okay, simple imputer is a class. So module will have class as well as methods, right? Okay. So we are using simple imputer class. So it is a module, impute is a module and it has a class called simple imputer and you have it. Now if you want to search, if you want to know more about impute, what are the other members of impute, what are the other methods and classes of impute, you can obviously go to the same website, scikit-learn, and it will give you the entire members of impute, what all it has, and explore other ways of, is there any other ways of missing values, replacing missing values. All the other ways will also be in the impute. Impute is one module which has everything related to missing value replacement. Okay, so your task for today is to go and explore sklearn.impute. What will you do? What will you do today?
Impute.
Yes, explore impute. Okay, so this is the first step. Now, what is the second step that we discussed?
Need to check if any outliers.
Categorical value. Okay, handling of
Categorical. Categorical value.
categorical value. Now, here again, we said 3 steps, right?
Yes.
Encode, column transform,
Yes.
and deleting one of
Delete
the
any
column.
column.
Okay, so we will do first encoding. Okay, and we'll do encoding, and the rest we'll see tomorrow. Okay, so I'm going to say we need label encoder. We need label encoder. Okay, we need label encoder for encoding. So this is also an sklearn. So I'm going to say from sklearn dot pre-processing. Yes. From sklearn pre-processing, okay, import label encoder. Okay, so now we are ready to encode. Okay, so we need to call label encoder, isn't it? So I'm going to say here LC equal to label encoder, and no values needs to be passed here. Okay, now here which column? X column we need to
X.
do the encoding. So I'm saying X
Yes.
all rows comma first column
First column.
equal to LC dot fit transform. Together only we are doing it. Fit transform what? Same. X all rows 0.
0.
Now you see we will print X here and see. Okay, let me have it here so that you can also try it later. I'm commenting this part. Okay, this part should not be printed. Instead, I want to see what happens after we have done column transform. Column label encoding dot fit transform. You see this?
Yes. Yes. Yes.
Columns have been encoded.
Yes.
North is 1, it will do in alphabetical order. So east
Yes.
will be
Alphabet.
0, north will be 1, south will be 2, west will be 3. This is west, west, west. Okay. So far we have seen how to encode and the categorical value. We still have to see two more things, right? One is column transform, and second thing is deleting. Deleting is easy. Column transform will take some time. That's why I don't want to do it today. Tomorrow when we connect, we will talk about how to transform. I mean, how to um, transform the column. Yes.